Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 12, 2025, just yesterday. This paper unveils an open recipe and a real-time agent that finishes the entire 5-hour Mondstadt main storyline at near-human efficiency, and Zero Shot completes a 100-minute mission in Wuthering Waves, plus the full 5-hour first chapter of Honkai Star Rail. The paper is titled Lumine, an open recipe for building generalist agents in 3D open worlds. And as we'll see later, the implications for generalist agents are quite significant. Alright, Figure 1 shows a generalist game agent that perceives the screen, reasons as needed, and acts with keyboard and mouse in a continuous loop. The left panel highlights a human-like setup, which signals end-to-end control without special game interfaces. The right panels illustrate 4 capabilities: exploration, strategy, interaction, and planning. The thought bubbles depict optional inner monologue, meaning the model generates brief reasoning only when the situation benefits from it. Well, Figure 1 showed the loop. Table 1 compares general-purpose agents on open-world scope, task duration, perception, instructions, reasoning, latency, and interface. The table highlights Lumine as the only system that spans open worlds with a 5-hour horizon and real-time control. Stepwise reasoning here means fixed percept thinking, whereas adaptive reasoning triggers thoughts only when needed. Interface K&M means direct keyboard and mouse rather than game APIs. So, Figure 2 shows the playground that makes the task hard, with scenes spanning exploration, puzzles, combat, and user interface menus. The collage conveys that an agent must handle free movement like climbing and gliding, plus precise actions like fishing and card battles. Multi-level reasoning here means planning across several steps, such as solving a puzzle while tracking objectives. The breadth signals why real-time control and adaptive reasoning both matter. Okay, Figure 3 shows how the agent turns pixels into keyboard and mouse actions using a perceive, reason, act loop. The top tiles represent observations from frames, while the pink tiles mark optional thoughts that appear only when needed, which keeps control fast. The bottom tiles denote action chunks that execute continuously. The long blue block integrates recent images, past actions, and any latest reasoning to decide the next move. So, Figure 10 reports instruction following on simple tasks, showing the instruct model leading across all categories. It reaches over 80% success, which signals reliable short horizon execution. Average performance lifts strongly over the base model, with about a 61% gain. Combat sees the biggest jump, because language alignment stabilizes goal tracking and finishing moves. Collection, NPC interaction, and puzzle tasks also rise, reflecting steadier camera control and crisp user interface actions. Instruction following looked strong. Figure 17 visualizes how the agent completes a full story mission, mapping routes and timing across 5 subtasks. The left map shows red paths for movement and blue links for teleport jumps, which together trace the geographic trajectory. The right panel lines up screenshots with timestamps to mark steady progress to the finish. Lumine thinking completes the mission in 56 minutes. Fresh human players average 78 minutes. Expert players average 53 minutes. Alright, 2 takeaways stand out. A single vision language model can run real-time keyboard and mouse control for hours, and adaptive reasoning unlocks strong cross-game generalization without fine-tuning. The broader implication is a practical path toward decision foundation models for embodied, open-ended worlds. That is it for the AI Research Roundup. I am Alex. Thanks for listening.